This presentation explores the systematic review of industrial wastewater management. It examines the challenges and enablers in this critical field. This study provides a systematic literature review encompassing industrial wastewater management research from the past decade, examining enablers, challenges, and prevailing practices. Originating from manufacturing, energy production, and diverse industrial processes, industrial wastewater's handling is critical due to its potential to impact the environment and public health. The research aims to comprehend the current state of industrial wastewater management, pinpoint gaps, and outline future research prospects. The SLR methodology involves scouring the Scopus database, yielding an initial pool of 253 articles. Refinement via search code leaves 101 articles, followed by abstract screening that reduces articles to 79, and finally 66 well-focused articles left for thorough full-text examination. Results underscore the significance of regulatory frameworks, technological innovation, and sustainability considerations as cornerstones for effective wastewater management. However, substantial impediments like inadequate infrastructure, resource constraints, and the necessity for stakeholder collaboration still exist. The study highlights emerging research domains exemplified by advanced technologies like nanotechnology and bioremediation, alongside the pivotal role of circular economy principles in wastewater management. The SLR offers an exhaustive view of contemporary industrial wastewater management, accentuating the imperative of an all-encompassing approach that integrates regulatory, technological, and sustainability facets. Notably, the research identifies gaps and opportunities for forthcoming exploration, advocating for interdisciplinary research and intensified stakeholder collaboration. The study's insights cater to policymakers, practitioners, and researchers, equipping them to address the challenges and capitalize on prospects in industrial wastewater management effectively. Water is an essential resource for industrial operations, and its availability, quality, and reliability can have significant impacts on business operations and profitability. Industries rely on water for a variety of purposes, including manufacturing processes, power generation, agriculture, mining, and oil and gas production. Effective management of water resources is therefore critical for industries to ensure the sustainability and longevity of their operations. One of the key challenges in managing water utility in industries is the disposal of wastewater. The discharge of industrial effluents into water bodies can cause pollution, leading to severe environmental and health consequences. To address this issue, industries are adopting various wastewater treatment technologies, including physical, chemical, and biological treatment methods. In a nutshell, water utility in industries is crucial for sustainable industrial development, and its efficient management is essential for minimizing the environmental impact of industrial activities. The adoption of water-efficient technologies and effective wastewater treatment methods are crucial for achieving this goal. There exist various types of industries that heavily depend on water for execution of their respective processes. Like the textile industry requires substantial water for dyeing, printing, and finishing processes. A single cotton t-shirt production can consume over 2,500 liters of water due to these processes. The paper production involves pulping and bleaching, both of which demand significant water. Wastewater treatment, reuse, and recycling, as well as efficient use of water resources and pollution prevention, are important. According to Atangana and colleagues, there are several existing wastewater management techniques and practices that are used in industries to treat and manage their wastewater. This involves the use of microorganisms to break down and remove pollutants from wastewater. The most common biological treatment processes include activated sludge, trickling filters, and anaerobic digestion. This includes the use of chemicals such as coagulants, flocculants, and oxidants to remove pollutants from wastewater. Chemical treatment processes include precipitation, oxidation, and adsorption. It consists of the use of physical processes such as sedimentation, filtration, and membrane separation to remove pollutants from wastewater. This involves the use of advanced technologies such as reverse osmosis, ultrafiltration, and ion exchange to remove specific pollutants from wastewater. Table 1 outlines the challenges, enablers, specific issues, and corresponding opportunities or scope associated with industrial wastewater management in various sectors. The above table aims to offer a comprehensive overview of the complexities and potential solutions in addressing these challenges across different industries and sectors. In addition to these techniques, there are also several practices that industries can adopt to manage their wastewater more effectively. Water conservation reduces the amount of water used in industrial processes through measures such as process optimization and reuse. pollution prevention implements the measures to prevent or reduce the generation of pollutants in the first place, such as process modification and use of cleaner technologies. Similarly, sustainable wastewater management adopts a holistic approach to wastewater management that considers the entire life cycle of wastewater from generation to disposal. There is growing awareness among industries about the importance of wastewater management and the need to adopt sustainable practices. Many industries are recognizing the potential benefits of effective wastewater management, including reduced environmental impacts, improved public health, and enhanced business sustainability. However, there are still significant challenges that need to be addressed to ensure that industries are fully aware of the importance of wastewater management and are taking effective measures to manage their wastewater. These challenges include the lack of regulatory enforcement in some regions, limited resources for wastewater management, and a lack of understanding of the potential impacts of poor wastewater management practices. Moreover, there are several reasons why existing wastewater management techniques may fail or be ineffective in achieving desired outcomes. Many wastewater treatment facilities use outdated or insufficient treatment technologies that are unable to effectively remove pollutants and contaminants from the wastewater. As a result, untreated or partially treated wastewater is released into the environment, leading to environmental degradation and health risks. Even the most effective wastewater treatment technologies can fail if they are not properly maintained and operated. Inadequate maintenance can result in equipment breakdowns, clogging of pipelines, and other issues that can lead to reduced treatment efficiency and increased operational costs. Many wastewater treatment facilities, especially in developing countries, lack the financial resources to invest in modern and effective treatment technologies and infrastructure. This limits their ability to effectively treat wastewater and prevent pollution. In some cases, the failure of wastewater management techniques may be attributed to a lack of public awareness and engagement. Without public support and participation, it can be challenging to implement and sustain effective wastewater management practices. Table 2 shows an umbrella review. The study was limited to wastewater management in urban cities only. Important wastewater issues like strategic planning, maintenance, and its continual development were totally ignored. Lack of comprehensiveness was observed, as in case of advanced oxidation processes, very less scale-up trials had been considered. Work on techno-economic assessments, optimization of reactor design, solar light innovations, and upcoming catalytic technologies were partially touched. It doesn't talk about the treatment of priority or banned substances in wastewater and restricted its study only for Istanbul. Would not followed any standard review procedure like PRISMA, ROSE, or SIG guidelines. Moreover, nothing was discussed to handle secondary pollution caused by emisinas due to further release of adsorbed contaminants. This review approach is considered conventional and assumes that all studies are equally valid. The review found a limited amount of literature regarding the mobility of charge carriers, insufficient band gap, inadequate ability to separate charges, and limited capacity for absorbing light in BBPs. Realized citations from number of informal sources like web pages or sites whose credibility should be mentioned. Depicted quite a few applications of selective oxidation in real scenario. Covered techniques utilized since last decade only. Not many studies were cited about the catalyst, which is an essential part of solar-powered degradation of pollutants. More elaborative discussion was needed to improve the performance, stability, and capabilities of solar-based wastewater treatment plants. Only xenobiotic contamination was focused since last decade. Not followed any specific scientific method which inculcate unwanted characteristic of non-replication in the review. Scope was also less emphasized in conclusion section. Limited literature on effective treatment of viral contaminated wastewater led to a non-rigorous review. The study suggests using multiple treatment barriers for complete removal of viruses from wastewater and taking extra precautions. Focused on micropollutant removal in Europe, suggesting upgrades to certain urban WWTPs, but did not address cost-effective elimination of a wide range of micropollutants. The review focused on recent adoption of AI was based on a few case studies. The AI proposed model relied on empirical experience and only validated with historical data. Deals with specific technology, and the study were observed more descriptive in nature instead of integrating or synthesizing revolutionary outcomes. Search strategies were not mentioned in details. It was more or less a qualitative review and focused in urban African areas mostly. Seems to be overstating the strengths of hydroponics and understating the real-world constraints. Proposed approach was appropriate for decentralized wastewater treatment only. Qualitative aspect of China's wastewater management had been delineated without any proper synthesis and conclusions. The study seemed to be rehashing what's already been said. Lack of integration and synthesis had been realized. Study conducted with sufficient number of papers but still lacking in systematic execution of a reviewing process. Did not mention assumptions or limitations of present study. Emphasized more on energy savings by bringing optimality in design and operational aspects of plants rather than relying on some sustainable energy alternatives. No quantitative comparison of technologies was provided, and important factors such as operational costs, environmental impact, and low efficiency in diluting metal concentrations were not emphasized. Study covered only last 10-year literature and lacked repeatability as it was not followed any systematic standardized approach of reviewing. A lack of transparency replicability might be the major concern. Referred a few latest or upcoming papers. Discussed only the licensing importance to protect wastewater, though emerging contaminants were still out of the regulations. This depicted the potential of systematic review paper and put light on its acceptability, clarity, and effectiveness. It is obvious from above figure that though systematic literature reviews (SLRs) are generated from less number of references, but still their comparative citations are impressively high. This fact uncovered the hidden potential of SLR and motivates further to perform a comprehensive systematic review without ignoring its descriptive part. Overall, the methodological rigor, comprehensive coverage, and trustworthiness of SLRs contribute to their high citation count compared to other types of review papers. Researchers value SLRs as authoritative references that offer reliable insights, help bridge knowledge gaps, and stimulate future research in the field. SLRs play a critical role in evidence-based practice by providing reliable summaries of existing research. Researchers and practitioners from diverse fields reference SLRs to inform their decisions and practices. While systematic literature reviews SLRs offer valuable insights, potential limitations should also be acknowledged. These include publication and language biases, database selection, varying study quality, subjective inclusion criteria and timeframes affecting relevance, potential errors in data extraction and synthesis, overlooking gray literature, expertise bias, and capturing only up-to-date trends. Recognizing these limitations ensures a balanced interpretation of findings, stresses the need for cautious conclusions, and highlights areas for future research. This transparency enhances the credibility and reliability of SLRs while guiding further exploration in the field. Best review paper is the article which everyone wants to read and cite in their own work. Citations play a crucial role in assessing the significance and influence of a review paper. High citations indicate that the paper has been widely recognized and referenced by other researchers, suggesting that it has contributed substantially to the field's knowledge base. Such recognition signifies that the review paper has influenced subsequent research, discussions, and developments. In order to design an appropriate systematic review, necessary recommendations can be taken after regressing existing independent factors XS with corresponding Y, i.e., citations in which we are interested. Presently, the year of publication, number of papers reviewed, and method type of review have been considered as independent factors XS, which can affect the dependent factor Y, i.e., citations of the publication. An effort has been made to regress relationship between citations Y and with above XS by using last 10-year WW review data. Data is fed into Minitab for appropriate model fitting and found following results. The p-value less than 0.05 depicted the statistical significance of all the considered X's to raise the overall citations of a WWM review papers. The RSQ, 79.8%, proved the efficacy of quadratic model on present review dataset. The three plots of cited by versus X variables are having non-gray background, and their scatter plots reflected sufficient importance of factors like year of publication, number of papers reviewed, and method or type of review performed. These finding implies that year of publication contributes to citations, underlines the importance of staying up to date with the latest research trends. Incorporating a higher number of papers reviewed enhances the comprehensiveness and depth of the review, potentially attracting more citations as a valuable resource. Selecting the appropriate method of review, such as systematic or critical approaches, can also impact citations by ensuring rigorous methodologies and in-depth analyses that contribute to the review's credibility and authority. Therefore, these findings provide insights for researchers aiming to design impactful SLRs, guiding them to strategically consider these factors to maximize the potential for higher citations and broader influence in the field of wastewater management. Model building sequence illustrated the relative importance of all the independent factors XS along with their interactions, like square of papers reviewed are more important, p equals 0.001, than paper reviewed as a factor. Similarly, year of publication and type of review are not having much significance, but their interactions with number of papers reviewed are statistically important. Relative importance of understudied factors are drawn with help of linear bar graphs, showing year of publication has least significance, while number of papers reviewed has maximum influence on the citations y. The bar graph reveals that year of publication has the least significance, suggesting that the age of a paper does not necessarily dictate its impact or influence. On the other hand, the number of papers reviewed emerges as the factor with the highest influence on citations y, indicating that the thoroughness and comprehensiveness of the review process play a pivotal role in attracting citations. This highlights the importance of conducting comprehensive literature searches and including a substantial number of relevant papers in systematic literature reviews. Researchers and authors should prioritize the depth and breadth of their reviews to enhance the likelihood of higher citations. Moreover, these implications highlight the dynamic nature of research impact, where a comprehensive and up-to-date approach can outweigh the effect of publication year in contributing to a review's overall citations. The above facts will be quite helpful to design a good systematic review paper on WWM, which will have maximum number of citations and popularity. Seems to be perceived as more authoritative, driving higher citations and impact within the research community. Minimizing bias is imperative in conducting a systematic literature review, SLR. Ensuring that the review process is free from bias is essential to maintain the credibility and validity of the findings. Bias can arise from various sources, such as selection bias when choosing studies, publication bias in favor of positive results, and interpretation bias in analyzing the data. To mitigate bias, researchers must establish clear inclusion and exclusion criteria, use comprehensive search strategies, and transparently document the review process. Additionally, employing multiple reviewers and resolving disagreements through consensus can help reduce individual bias. By taking these precautions, the SLR results are more likely to accurately reflect the true state of the literature, enhancing the overall quality of the review. Increasing the validity and reliability of a review is essential to enhance the credibility of its findings. Validity ensures that the review accurately represents the true state of the literature, while reliability ensures that the review can be replicated with consistent results. Validity is crucial because it assures readers that the conclusions drawn from the review are trustworthy and relevant to the research question. Reliability, on the other hand, ensures that the review process is transparent and unbiased, enabling other researchers to replicate the study and confirm its results. By prioritizing validity and reliability, the review gains greater trustworthiness and becomes a valuable resource for decision-making, policy development, and further research in the field. Next, the utilization of systematic and rational methods to synthesize the results of multiple studies offers several advantages that contribute to a more robust and accurate understanding of the evidence. By applying a systematic approach, researchers ensure that all relevant studies are included, minimizing the risk of bias and selective reporting. This comprehensive inclusion enhances the reliability of the conclusions drawn from the synthesis. Additionally, the rational method allows for the aggregation of findings across studies, providing a clearer and more nuanced overview of the patterns, trends, and inconsistencies present in the literature. This approach facilitates the identification of common themes and differences, enabling researchers to make more informed assessments and draw meaningful insights. Ultimately, employing rational methods enhances the credibility and reliability of the synthesized results, making them more valuable for informing decisions, shaping policies, and guiding future research directions. SLRs are esteemed for providing higher-level evidence due to their rigorous and systematic methodology, encompassing thorough literature searches, quality assessments, and standardized data extraction. This meticulous approach reduces bias and ensures comprehensive synthesis, enhancing the credibility of deductions. Policymakers and practitioners value SLRs as reliable sources that inform decision-making and policy formulation across various domains, including wastewater management. So a strong need of conducting a rigorous and transparent SLR for identifying, selecting, and analyzing relevant studies has been felt. This helps to minimize bias and increase the validity and reliability of the review. It must include the use of rational methods to synthesize the results of multiple studies, providing a more precise estimate of the effect size of an intervention or exposure. A SLR illustrating higher level of evidence than any other type of reviews is observed to be the need of the hour. Manuscripts in the review were of high quality, relevancy, and strictly met the inclusion criteria. Conducting a thorough quality assessment also helped to reduce bias and increase the validity and reliability of the review. Now, as per the predefined objectives, these 66 papers have been strictly scrutinized to skim out the challenges and enablers in WWM. It has been found that 18 papers are written about wastewater and its other operational aspects which are beyond the scope of present SLR. After neglecting these, only 48 studies have been explored to assess concerned challenges and enablers in the field of WWM. Necessary qualitative analysis was carried out as depicted in Table 4 ahead. This section of the review paper provides a comprehensive comparison and verifications of its findings with existing literature. Notable trends and patterns in industrial wastewater management are highlighted, drawing parallels with prior research. The review identifies common challenges and enablers in the field, aligning its observations with established studies. Several previous works have addressed challenges similar to those identified in this review. Ruan and colleagues discussed the impact of water scarcity on wastewater management, echoing the concern over limited water resources raised in our study. Similarly, Benzidia and colleagues emphasized the importance of sustainable treatment processes, aligning with our emphasis on the low sustainability of current treatment methods. This review finding on inadequate effluent discharge standards resonate with Jean and colleagues' assertion of questionable WWTP effluent quality. Next, the emphasis on a circular bioeconomy and resource recovery in this paper aligns with the approach advocated by Liu and colleagues in their study of sustainable wastewater practices. Our recognition of the significance of data privacy and algorithmic development for deep learning in wastewater management aligns with the concerns raised by Ho and Goethals in their discussion of challenges in implementing AI technologies. In terms of research methodologies, the use of systematic literature review methodology parallels that of Kourimides Dane and colleagues in their exploration of water management challenges. Similarly, the integration of umbrella review and critical literature review in this work finds resonance in the approach adopted by Wolfart and Wagner in their comprehensive study of wastewater management enablers. In brief, this review paper's findings corroborate and extend existing knowledge in the field of industrial wastewater management. A study by Sindane and Modley conducted a similar review of challenges in wastewater management across different industries, corroborating our identification of common issues such as water scarcity, pollution, and inadequate treatment processes. Similarly, McQuaid and colleagues examined enablers for sustainable industrial wastewater management and highlighted the significance of effective policy support, echoing our emphasis on the importance of government regulations as a key enabler. To validate our findings regarding the role of technology, the research by Waywale and colleagues investigated the integration of AI and IoT in wastewater management, aligning with our recognition of emerging technologies as potential enablers. Moreover, the work of Vertiger and colleagues demonstrated the relevance of multi-agent systems for complex urban wastewater management systems, reinforcing our identification of multi-agent systems as a challenge. The focus on resource recovery and circular bioeconomy aligns with the work of Liu and colleagues, which emphasized the importance of transitioning from a linear to a circular approach in wastewater management. Additionally, the concerns about the presence of microplastics and nanoparticles in water, highlighted in this review, are echoed in the study by Ferreira and colleagues affirming the observations of this SLR. The consistent alignment of the observations of this SLR with previous research accentuates the validity of the challenges and enablers it identified in industrial wastewater management. By harmonizing the results with established knowledge, this SLR has contributed to a more comprehensive understanding of the field and provides valuable insights for future research and practice. Table 4 shows a qualitative analysis. Deep learning methods are still in their early stages of implementation within the water sector. Research challenges related to privacy of data, algorithmic development, reliability, multi-agent systems, and digital twins need to be addressed in order to apply deep learning effectively to urban wastewater management, sludge production, and management in case of treatment plants of textile industry effluents. AOPs have high operating costs and reuses of catalytic materials are still not possible. To improve corporate performance by making process economical and eco-friendly are another giant challenges to achieve high energy savings. To enable adaptability and commercialization of the MFC technology are some of the major bottlenecks. reduction of aeration costs, and to assess the effect of elevation on the process of municipal WWT are needed more insights. Urban wastewater management requires accurate prediction of water demand, timely detection of leakage and contamination, effective evaluation of sewer defects, reliable prognosis of wastewater system status, regular monitoring of assets, and proper assessment of urban flooding risks for operational excellence. Among the emerging advanced oxidation processes, modified electrochemical oxidation, gamma radiation, and plasma-assisted systems show promising potential for sustainable wastewater treatment due to their environmental compatibility, safety, and ability to efficiently transform emerging contaminants. Scaling up trials and a thorough understanding of their reaction kinetics in complex wastewater matrices are essential for assessing the technical and economic feasibility of full-scale processes. Algae-based wastewater treatment plants are emerging as a mandatory future solution for wastewater treatment, replacing traditional methods like activated sludge to reduce carbon footprint and operational costs. To ensure successful deployment of modern WWTPs, a comprehensive evaluation methodology is required, considering both qualitative aspects and quantitative aspects. The future application of promising groundwater tracers will provide wastewater treatment plant operators and regulatory authorities with a more definitive tool for assessing groundwater contamination caused by site operations. The elevation along with temperature of the WWTP acts as a driving agent to reduce the aeration expenses in biological WWT of municipal wastewaters. The activated sludge process is influenced substantially by various environmental conditions like temperature of atmosphere and its pressure, along with relative humidity in different seasons at various latitudes and heights. The MZenes are a group of materials that consist of transition metal nitrides, carbides, or carbonitrides, which have excellent properties such as high conductivity, hydrophilicity, structural stability, and sorption capacity due to their versatile surface chemistry. They can effectively remove pollutants based on their own physicochemical properties and the chemical nature of the pollutants. Moreover, MZene-based nanomaterials are highly efficient in wastewater management. Bismuth-based visible light-sensitive photocatalysts are non-toxic, are cheap, and possess changeable configuration as well as excellent optical and chemical nature. These can be modified by doping, heterojunction, Z-scheme, etc., and can inactivate bacteria. The ozone treatment was effective in eliminating the estrogenic potential of MPs, making it a suitable method for their removal. To prevent an increase in endocrine loading in the water body after heavy rainfall, point sources such as rain overflow basins can be set up upstream of WWTPs. In addition, EBMs have been successfully used for compliance monitoring of estrogenic compounds. Not discussed. The utilization of solar energy in photocatalysis processes, solar thermal electrochemical processes, solar desalination of brackish water, and solar advanced oxidation processes has been demonstrated to be cost-effective and promising for the future of wastewater treatment. Challenges are toxicity and secondary contamination of nanomaterials while using MZene-based nanomaterials in the WWT. Pristine BBP has limitations such as poor charge carrier mobility, inadequate band gap, limited charge separation ability, and limited light absorption capability. Additionally, carrier trapping, carrier recombination, and thermal instability are also challenges. WWTPs release micropollutants, MPs, into nearby water bodies, particularly endocrine-disrupting compounds, EDCs, when they discharge treated wastewater. Worldwide, wastewater and activated sludge pose significant challenges. These arise from their production by all industries, laundries, and human settlements, among others. Energy storage systems pose a challenge for WWTPs due to the increase in overall expenses. Additionally, the need for immobilized catalysts and the intermittent nature of solar power are other challenges. Municipal wastewaters. The activated sludge process is influenced substantially by various environmental conditions like temperature of atmosphere and its pressure, along with relative humidity in different seasons at various latitudes and heights. The MZenes are a group of materials that consist of transition metal nitrides, carbides or carbonitrides, which have excellent properties such as high conductivity, hydrophilicity, structural stability, and sorption capacity due to their versatile surface chemistry. They can effectively remove pollutants based on their own physicochemical properties and the chemical nature of the pollutants. Moreover, MZene-based nanomaterials are highly efficient in wastewater management. Bismuth-based visible light-sensitive photocatalysts are non-toxic, are cheap, and possess changeable configuration as well as excellent optical and chemical nature. These can be modified by doping, heterojunction, Z-scheme, etc., and can inactivate bacteria. The new model of wastewater treatment focuses on involving multiple parties to enhance cost-effectiveness and address compliance issues. 3 conditions must be met to transition to this new model, including government support, implementing monitoring systems, and developing the capacity of actors involved. Since the effectiveness of current water treatment in eliminating SARS-CoV-2 is not confirmed, multiple treatment barriers should be used to ensure complete removal of the virus from water. However, additional scientific research is needed to develop effective viral disinfection strategies for wastewater treatment. Strategies for investigating wastewater treatment during viral pandemics could include regular testing of disinfectants, taking into account various factors that influence viral survival, evaluating performance in different environmental conditions, considering the impact of wastewater quality, and assessing the environmental effects of disinfection technology. Fungal and cases have the ability to convert micropollutants in municipal wastewater, which can reduce toxicity in harsh conditions, making them ideal biocatalysts for bioremediation. Fuzzy logic evaluation is an effective method for intelligent control of the aerobic stage in wastewater treatment. Soft sensors aided by AI provide accurate real-time and offline estimates of difficult-to-measure parameters in wastewater treatment plants, while single and hybrid AL methods can be used to estimate pollutant concentrations and develop monitoring and early warning systems for aquatic and atmospheric environments. Additionally, AL modeling can be used to predict short-term, mid-term, and long-term solid waste generation, and various artificial neural networks can be applied to solid waste recycling and reduction, which can improve the capabilities of wastewater treatment plants. Combining hydroponic systems with municipal wastewater treatment can decrease costs related to removing pollutants, as well as reducing the maintenance and energy requirements of traditional wastewater treatment methods. By using the treated wastewater for crop production, the system allows for the continual use of wastewater while simultaneously removing pollutants and nutrients, resulting in improved food security and environmental protection. This also helps reduce health risks to farmers, crops, and consumers that might result from exposure to wastewater. The development of modern WWTPs aims to transform them from facilities solely focused on removing pollutants to ones that also generate energy, recover water and fertilizer resources, and contribute to the overall urban ecosystem. Not discussed. The utilization of solar energy in photocatalysis processes, solar thermal electrochemical processes, solar desalination of brackish water, and solar advanced oxidation processes has been demonstrated to be cost-effective and promising for the future of wastewater treatment. The text emphasizes the importance of ISO standards to maintain quality and transparency in the application of life cycle assessment (LCA) methods in wastewater treatment (WWT). The challenges that arise in LCA applications in WWT are also discussed, such as the need to shift from pollutant removal to resource recovery, adaptation to new target compounds, and the development of regional factors. Additionally, the text highlights the need to improve the quality of data and reduce uncertainty, as well as better integration and communication with decision makers. To better anticipate the elimination of contaminants in centralized treatment plants, it is recommended to supplement traditional, heuristic, and other FATE models with more mechanistic approaches, given the significant advances in monitoring and detecting MPs, microplastics in wastewater. And not discussed. The factors that drive the water industry, such as GDP, water pricing, funding, and laws, should be carefully examined and analyzed. The integration of expert interviews, legislation, specialized literature, and engineering experience into the knowledge bases is one of the main achievements of this study. This methodology is presented as an essential tool that generates customized process flow diagrams, PFD, tailored to each specific case, taking into account the process unit interactions and user-specified requirements and objectives. Not discussed. An automated system that provides a multi-point analysis for measuring the turbidity of large volumes of wastewater effluent is available and can be easily replicated. Combining separation techniques with methods to evaluate particle size and chemical makeup seems to be the best strategy for handling wastewater. For a more comprehensive comprehension of the destiny and influence of engineered nanomaterials, ENM, connected with WWTPs, more accurate experimental designs with better measurement of ENM characteristics under the chosen test settings are needed. Not discussed. The approach of non-targeted scanning chemical profiling has a high potential for detecting unknown pollutants or new biological indicators. The development of new configurations for wastewater treatment plants is driven by legislation that requires stricter effluent requirements and the desire to make plants energy self-sufficient or even energy positive. In the future, groundwater tracers that show promise could be applied to give wastewater treatment plant operators and regulatory authorities a more definitive way to assess contamination of groundwater associated with the plant's operations. This slide contains no content to narrate. 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 In conclusion, this systematic review acts as a catalyst for informed decision-making in industrial wastewater management. By comprehensively evaluating challenges and enablers, we aim to inspire a transformative shift towards responsible and sustainable practices.